Hello. You should see the desktop. You should hear me. Does that seem okay?
Yes, I can hear you.
Okay, great. Thanks. Okay, I'm just bringing up some windows if they need. Okay. All right. So first, let me point out that there's another programming assignment, a new one. There's one due today using ML, and there's a new one due in 2 weeks. Okay. So actually, first, does anybody have any question about the one that's due today? Is there any question about the problem in the current programming assignment?
Yeah, I do have one question, Professor.
Sure.
One of the assignments, when you bring the head to the tail to the front and the head to the back, still showing the bracket. Is there a way to take this away?
Say again. I couldn't hear what you said.
I said when you bring one of the problem, you bring the head to the back and the tail to the front. One of the problem, I'm not sure if it was problem 6 or 5. You still seeing the bracket and the tail, not in the whole thing. If you want, I will share my screen, for example, to show you.
Okay, let me open it up. Maybe I can figure out what you mean by that. So that's problem. Which one?
Not sure if it's 6 or 5. Which one? Let me look and see which one. No.
5 takes in a triple and gives you back a pair.
That would be number 7. I'm sorry, number 7.
Oh, so okay.
So when I run it, you see the bracket in the what's called the tube or the list. I'm sorry.
I mean, like here it says cycle of the list.
Yeah. So the list has a bracket before the.
Oh, I can't hear you. Can't hear you.
Hello. Hello.
Yeah.
You hear me now?
Yeah.
Okay. So let me. Can I? Okay. What the meaning is?
I can turn on. Let's see. No, let's see. I don't think I can turn screen sharing on. I don't have a little button that says that like let other people share screen. I don't know.
It will be on the security, I believe so, or this stuff like this, or the privacy.
It was under security.
Yep.
But I still don't have it. Let's see. Let me look at there was under security. I checked allow participants to share screen. Is it turned on?
Let me see. No, you cannot start screen sharing while.
Oh, maybe I have to stop sharing.
Yes, you need to stop yours.
Let's see. So I'll stop sharing briefly. See if you can share.
Yep. Okay. So that's my screen, and that's the problem. When I do this,
oh, you're creating a pair. See, you're creating a pair that have. You're not creating a list.
Okay.
So you're returning a pair, not returning a list. So you don't want to build a pair, you want to build a list. You need to use the cons operator, the double quote, the double colon operator. You have to make use of the double colon operator.
Where's that would be, on the A or on the?
On the right-hand side.
So delete this and do that?
Well, actually, no, you can't. Oh, no, I'm sorry. You get rid of the quote you just put. What you need to use is you need to use the concatenation operator, the at operator.
Okay.
So see where you have the comma?
Yes, I see that.
Replace the comma with at sign.
With at sign?
Yeah. Okay. But now you have to put head in a list. So you put a square bracket after the at sign. And a square bracket where the parentheses at the end. See, now you're making a short list of one item, and you're concatenating it to what was the tail. Now, I think you need parentheses around TLA. Okay, now that creates the tail of the list. That's a list. Then you want to concatenate the very short list, that's one item, that's the head. Okay, so see, now you're taking a list and returning a list.
Okay.
Now try cycle of 1, 2, 3. Now get rid of the parentheses because cycle takes in, yeah, this is not Java. Yeah, see now cycle of a list is,
Okay, I'm sorry. Cycle 1.
yeah, there.
Okay.
See, you need to build a list. You were building a pair. So you had the two things you needed, but you put them in a pair. And so
Yes.
what we did is we changed it to take those two things and slap them together as a list. So you
Okay.
had, yeah, you look up above through the screen, you had tail of A and head of A, but you had them in the two sides, the two pieces of a pair. And then when you fixed it, you took the two things and concatenated them together. But you also had to take the head of A and make a list out of it by making it a one item list.
Okay.
Okay.
Thank
Yeah,
you.
it's a little bit, it takes a little while to get used to this idea of lists and pairs are not the same thing. And one of the things you're going to see, okay, stop screen sharing and I'll go. Okay, I'm screen. One of the things that we got to get really used to is that comparing Java and ML, actually, let me do it in a text file. This is something you're going to have to get really used to. In math and in Java, you call functions with parentheses like that, or like that, okay? So that's a function with one input, that's a function with two inputs. Now, when you switch to ML, this is not a function with two inputs. This is a function with one input. It's better to write it like that. The input is a pair. That's not a function of two inputs. That's a function that's a pair. Okay. Like here, I'll show you an example in the ML. Okay. Let's see. So as I write f of the pair xy is x plus y. Okay, that's a real simple example. It looks like Java at this point. Oh, I'm sorry. I forgot to say fun at the beginning. Okay, I forgot to, okay, all right. Now, f of, okay, 3, 4. This is looking a lot like Java, but it isn't. This function doesn't take in two things because I can do the following. I can say val Bob equals the pair 5, 6. Okay, I just make it z. Okay. Okay, now z is one thing that represents a pair. What's f of z? 11. Notice that f doesn't take in a pair. It doesn't take in, oh, I can write this, but it doesn't really quite mean what you think it does. That's just grouping z by itself. Okay, I'm not using Java notation. I'm using ML here. That's just actually grouping z by itself. The function is actually, you just write the parameter next to the name of the function. Okay, so there is no parentheses in a function call in ML. There's no parentheses like there is in math and Java. Okay, in ML, if you have a function of one number, you write it that way. If you have a function of two numbers, you write it that way. If you have a function of one pair, you write it that way. but that's one pair. Okay, here's a function of two pairs. Okay, that would be a function of two pairs. I can define a function like that by saying f of x comma y, u comma v equals, now I've defined a function that takes in two pairs, and I can just take x plus y plus u plus v. Don't have to do anything real interesting. Okay, so take this f and put it over here. Whoops, what did I do? Oh, I forgot the fun again. Yeah, if I'm switching to ML, I have to say fun of f. The function f, which takes in that pair and that pair, gives me back that answer. Okay, right now, how many input? What did I do wrong? Oh, I forgot the fun again. F-U-N. There. Okay. All right. F of 2 comma 3 and 4 comma 5. Okay. Notice that the parentheses are not the function call. The parentheses are the pairs that are the input to the function. Okay. Now, let me do the following. Remember, I have a pair X. No, I called it Z. I have a pair Z. Okay. So I can do the following. F of the pair 1, 3, and Z. I could do F of Z and the pair 5, 6. I could do F of Z, Z. Okay. Notice that that's two things. F took in two things. Each thing is a pair. Yeah. If I go back, because F takes in two pairs. Parentheses in this language, parentheses either mean grouping or they mean tuples. In Java and in math, parentheses mean grouping or function call. See, in Java, you use parentheses for two purposes. In Java, parentheses mean grouping or function call. Okay. In ML, the parentheses mean grouping, just like in Java, like in arithmetic expressions, okay, or tuples. Okay. There is no parentheses in function call. In function call, you write the name of the function and the parameters separated by spaces, no parentheses, no commas. Okay, no parentheses, no commas, like in Java. Okay, so function call is like this is, if this is ML, there's no parentheses in function call, so, and that's not a tuple, so that means that's just grouping 3 by itself. So that's just a redundant pair of parentheses. That's kind of like writing 1 plus 2. In almost any programming language, you can write that, just redundant parentheses. For example, and then you can write, there's just a bunch of redundant parentheses. That just gives you 3. Okay, that's a redundant pair of parentheses. That's not a redundant pair of parentheses. That's tuple. It's not grouping, that's tuple. And this one's tuple. Okay. Okay. So here would be a function call with one parameter. This is a function call with two parameters, the number 3 and the number 4. This is a function call with one parameter, a tuple. This is a function call with two parameters. You can do the following if you put parentheses like this. I don't know if those parentheses would be valid or not. They'd be like grouping, but I don't think you can group things around a space. Let's see. Let's see. I don't know if you can group things around a space. Didn't like that. See, it doesn't matter. It doesn't make sense to group around a space. Space isn't an operator. Okay, you have to group around an operator. Okay, so it doesn't make sense to put those spaces in there. Now, it would make sense to do that. Let's check it. This should make sense. Okay, read it from left to right. That first parentheses, what's it doing there?
It's creating a tuple.
Pardon me?
It's creating a tuple.
No.
Oh.
That very first read it from left to right. That parentheses, what's it doing there? Remember, parentheses only do two things: grouping or tuples.
It's grouping.
Why is it grouping? What is it grouping?
Just one tuple of.
Yeah, it's grouping the tuple by itself. It's like what I wrote up here when I grouped the number 1 by itself. What's the second parentheses doing?
Tuple.
Creating a tuple.
Yeah, beginning a tuple. The closing parentheses ending the tuple. Now you close the group. The group is a simple group. It's just a group that has the tuple 3, 4. Open another group. The group only has the tuple 5, 6 in it. Okay. Suppose I get rid of those two and put a comma there. What's this first parentheses doing?
Now to create a tuple.
And what's it a tuple of?
Two tuples of 2
Yeah,
ints.
2 tuples. And it's the comma in here that makes it a tuple. See, that parentheses, you don't know if it's grouping or tuple until you scan ahead and see what's coming up. So we don't know what that parentheses is doing. We don't know what that parentheses is doing. Oh, we see a comma. So that means that thing should be a tuple. Okay, see, that parentheses, comma, means that guy's a tuple. Close the tuple. So now we've got a tuple. That comma says that this one is beginning a tuple. So this is a tuple of tuples, but my function doesn't take in tuples of tuples, so it gives me an error. Okay. What if I delete that comma? Here's a tuple. Here's a tuple, but there's parentheses around the tuples. Is this forming a tuple?
No.
Because why?
Because there's no comma in between them.
Right. Okay. Is it doing grouping?
Yes.
It's trying to do grouping, but it's not.
No.
Why not? It's not doing tuples, so it ought to be doing grouping, but it's not really doing grouping. Why not?
Because you didn't specify in the function declaration.
No. If you group, what do I say? You have to group around what?
Operator.
An operator. There's no operator in there. See, there's just space. Space is not an operator. So we saw that. See, that was this example up here. See, we're back to this example up here where you were grouping. Oh, not that example. Oh, I erased it already. You can't group around space. That's not a tuple, and that's not grouping. That's just not syntactically correct. That makes it a tuple. That makes it grouping. You know, that makes it grouping. Okay, but like that, it's just, yeah, it's trying to be, it doesn't work as a tuple because there's no comma. It doesn't work as grouping because there's no operator. You put a comma there and the parentheses become tuple. You put a plus there and the parentheses become grouping. Okay. And again, there's no parentheses in function call unless you're passing tuples as a parameter. But then the parentheses are part of the parameter. They're not part of the function call. Okay. So get in the
So it's
habit
kind of like
of,
Haskell, like
sorry,
it's kind of like Haskell in the way.
like what?
Haskell.
It's exactly like Haskell. Yeah, Haskell got this idea from ML. ML came first and Haskell came second. And essentially, it's kind of like the relationship between C and C++ or C and Java. Haskell was sort of a modernization and an updating of ML, just like Java is kind of a modernization and updating of C++, and C++ is an updating of C. They're in the same. So ML is in the Haskell is in the family that ML is from. Okay. So yeah, this is the same notation. Another one that uses this notation is F#. Microsoft's F# language is another language derived from ML. So this is also the notation that F# would be using. So ML, F#. Another one you've probably never heard of is a language called, well, there's one called Camel, and then there's OCaml, which are two variations on ML. So I forget what the CA stands for. I don't even remember what the CA stands for, but I think it had something to do with the people who wrote it. And the O here is objective. It's like C++ was an objective version of C. This is an objective version of Camel. And then there's Haskell. You know, these are the languages that are, these are all descendants of ML. Okay, those are the ones that are out there now. And they all use this notation of writing a function and then writing the parameters after the function. Okay, yeah, you write the function and then you just write the parameters after the function with spaces between the parameters. So write the name of the function, space, parameter, space, parameter. Yeah, and if there's parentheses, it's because of the tuple. Now there could be grouping in my function call. Remember this function, I'm going to x, y equals x plus y. Okay, that function would be the sum of two ints, because plus takes either two ints or it takes two doubles. By default, if you don't tell it otherwise, it takes two ints. If I want it to take in two reals, I have to say real. But then I need to group that around that operator. The operator is the type declaration operator. Because of the order of operations, I have to do it like this. Otherwise, the order of operations gets messed up. So this guy is grouping. It's grouping around that operator. You can go over here. What did I do wrong here?
The function doesn't have a
Oh,
name.
I forgot to give it a name.
Yeah.
I forgot to give the function a name. I'm defining the function f. I'm just keep using the name f. I forgot to give it I forgot to give it a name. So the function f. See, now if I went and got rid of those grouping, I get a syntax error because now the order of operations is wrong. The X is about, it's F of parameter X, and then the colon looks like another parameter, because I can put, I could put spaces there. What it's thinking now is that F has got a parameter X, a parameter colon, and a parameter real, and a parameter Y. And it's saying that doesn't make any sense. Colon can't be a parameter, the word real, but see, it's F space, variable, space, something, space, something, space. And the syntax is that parameters are separated by spaces. I need to group that parameter with that operator and with that type name. I need to group them. Okay, now I've grouped them, so that's all one parameter. Okay, the parentheses are grouping now. They're not Java parentheses, like they're not Java-like parentheses of defining a function like in Java. They're grouping the X and the real around that operator colon, which means type of. X is type of real. Okay. Right. So, and same if I wanted to give Y a type, I'd say Y real. Okay. And then I have to group around that because of the order of operations. I have to group around that. So the second one's redundant with the first one. Yeah, if you've made one of them real, because plus takes two reals or two doubles, then they both become real. The parentheses here are not part of the function definition. They're not part of the syntax of functions like they are in Java. The parentheses are grouping around that operator there and grouping around that operator there. Okay, and there's a funny little syntax in Java, in ML. That seems to be a pointless grouping. You know, it's like over here, I said that, you know, you can group around the one, it seems to be pointless, and you can group around the two, and it seems to be pointless, and it is. Those are redundant grouping. This is not redundant grouping. This one ends up not being redundant because of a quirk in the language. Does anybody remember what is that pair of parentheses really doing for you? It's grouping the Y by itself, but what's the reason for having it there? We mentioned it in class the other day. What's it doing? What's this doing?
Saying it to real.
Saying what's a real?
The Y.
No, it's not saying that Y is a real. That would go inside here.
You want the function to return a real?
Yeah, it's the return type of the function. See, it's coming after the grouping is funny. The grouping is there to essentially say that I'm at the end, that's the last parameter, and then this is the return type of the function. Now ML goes here and says plus takes in two reals or takes in two double, or takes in two ints or takes in two reals. You want the result to be a real, so that makes these guys both real. But this was on the return type of the function. Now let's see, if I delete those parentheses, it still worked. And in this case, that real is grouped with that Y. It's kind of a quirky thing. The order of operations in ML can be really confusing. This one actually is on the Y. I didn't need that pair of parentheses. That's a redundant pair of parentheses there. Turns out most people would put them in there, but that's actually a redundant pair of parentheses. So without them, that's the Y being typed. But you can't do that for the X. This won't work. You need the parentheses around this one for the last parameter, you can put a colon and then a type, and then that type is on the last parameter. On the other hand, if you put a pair of parentheses around the last parameter, now you're putting a type on the return value of the function. Okay, and if you play around with these, they're not all the same thing. I can give you examples of functions where it matters whether you're putting a type. Well, here, I'll put a type on that guy. Okay. I want y to be an int, but I want the function to return a real. Okay. If y is an int and the function returns a real, over here, this has got to be the sum of two reals or the sum of two ints. But I want the result to be real, so this has to be the sum of two reals. But y is an int, so I need to convert it to a real. So now the function takes in real int and returns real. Okay, so that colon is the return type because of the parentheses there. That colon is the type of the parameter. Okay, if I delete the parentheses now, that won't work either. This will be the type of y, but this is just messed up. This one's got the wrong order of operations now. So the syntax is type of the parameter. And most people, if they're typing a parameter, put parentheses around it. Well, even though it's not always needed, if you're typing a parameter, put parentheses around it. So for example, right now, x is real, y is int, and the return type is real. Some of those types are redundant. They don't need to be there. But now I'm saying that the function takes in an x that's real, takes in a y that's int, and returns a real. Okay. And in fact, all of those types are redundant in this case. All of them are, except I could get rid of that. Why is this going to work? ML didn't actually need any of that other type information. What does that do? What does calling the real function with y as a parameter tell me?
Tells you y is an int.
Yeah, because I have to convert an int to a real. Okay, so y is an int. So y is an int. So I know that. But this is a real, so I'm adding a real. Now what does that tell me?
X is a real.
Because,
Y is being converted to a real.
and what does plus take?
Either int and an int, or a real or a real.
Yeah, it has to be two ints or two reals. We now know that plus has a real on its right-hand side, so it must have a real on its left-hand side, so x is real. Okay, so this guy ended up forcing the types of all the variables. This guy ended up forcing all the types all by himself. So I didn't need all the type information that I put up there. This one by itself made all the types. Okay, now on the other hand, if I get rid of that, now it's back to int plus int. And if I want it to be a real, I have to say somewhere in there, I have to say if I want it to be real, real goes to real, I either have to say x is a real, y is a real, the return type is a real, or I have to, like here I can do the following. I'm saying that the return type of this plus, not of the function, this is the return type of the plus. The return type of plus is real. Well, if the plus is returning a real, then that means that the inputs to it are real. So that means X and Y are real. So now I'm back to real to real. On the other hand, I could have said that Y is a real. If I tell you that Y is a real, well, then everything is a real because Y is a real. So over here, sum of real must be also real here. So the X takes in a real, and then the sum of two reals is a real. So I get real, real, real. Okay. So ML figures out most types, but sometimes you have to give it clues. So for example, the key examples, well, the key problem is addition and multiplication. By default, addition and multiplication take in either two reals or two ints, and by default, they'll take in two ints. And if you want them to be reals, then you have to force the issue. So you have, in this case, if I want that to be a sum of reals, I have to force it somehow. Either, and I can do it in a lot of ways. Force X to be a real, force Y to be a real, force the function to return a real, declare X to be a real over here. I can declare X to be a real on either side of the definition. That'll work. Or I could force the return type of the plus to be a real. Somewhere I have to say I want a real result. So I have to force the issue somehow. Okay, but parentheses here are grouping. All those were grouping parentheses. Okay, none of those were tuples, and there's no parentheses in function calls. Function definitions and function calls don't use parentheses in ML. Okay, so get rid of the habit of thinking of functions like in math, where don't look at that and say f is a function of two variables and it takes in 3 and 4. In ML, that's a function of one thing. The thing is a tuple. Okay, and this is a function of one thing. The thing is a triple. But f is only taking in one thing. The thing it's taking in is a composite thing. It holds 3 numbers. Okay, and here the function's taking in a composite thing that holds 2 numbers, but it's taking in only one thing. It's a function of one parameter. Okay. Okay. Now, any other question from the homework? Because that was a long, the problem you were having was confusing the role of parentheses. Okay. So what about other questions from the homework? Okay, well, let's go and talk about patterns. Okay, I want to talk about patterns. Okay, so this isn't up on the website yet, but well, actually, there's a version of it from this. This is, if you go back to the website. I've added a little bit more. This is a file that we started talking about in class last week, and I've actually lengthened this file. So I'll put a new version up of it. There'll be a new version of it up here after class. So here's the new version, but this is the discussing patterns. Patterns are tricky. They're real easy to get confused, and I've tried to explain them in a way that's a little bit different than the way they're explained in other books. And I think this maybe help explain what's going on. Okay, the key idea is that we're going to think of a pattern as the left-hand side of an assignment. Okay, so you're declaring a variable, you have this thing called a pattern, and you set it equal to a value. Okay, the simplest kind of pattern, it would be val x equal 5. Okay, that's what you're used to. But ML lets you do a lot more complicated things. Okay, so like the next pattern says val w is the pair cat 5. Okay, but it's still letting this variable be that value. Here's where things get real interesting. On the left now is what we call I mean, these are patterns. That's a simple pattern. That's a simple pattern. Here's a more interesting pattern. I'm saying my value is the pattern, a pair, X and Y, where X and Y are variables. Then on the right is a value. And what ML does is it matches the pattern to the value and gives the variables in the pattern the appropriate value. So for example, if you match this pattern to that value, X is 5 and Y is cat. See, that's very different than over here where I just said W is a name for the pair. Here I said that W is a name for the pair 5, cat. Here I'm saying match this pattern with this value. Now, matches don't always have to succeed. If the match succeeds, if the pattern has the same structure as the value, then the match succeeds. Okay. Now look at this one here. This one's a little bit trickier. The pattern is a pair of things. X is going to be named, is going to be the name for the first thing in the pair. Y is going to be the name for the second thing in the pair. Now you look on the right. Does that match the pattern? Is that a pair of two things? First thing, second thing. So X is 4 and Y is the pair 5, 6. Because this value matches that pattern because the pattern says a pair of two things, and this guy's a pair of two things. Just like this was two things, a number and a string, this one's two things, a number and a pair. Okay, now flip it over. Match a pair of things. X is the first thing in the pair, Y is the second thing in the pair. Okay, now if I do another one in here, like if I put val X comma Y here and wrote 4, that'll fail. 4 is not a pair. So that match would fail. If I wrote 4 comma 5 comma 6, that match fails. Because on the left, the pattern says a pair of things. The value on the right is a triple of things. Now, you might have said put the 4 in X and 5 in Y and ignore the 6, but that ML doesn't do that. There are some languages that might do it that way. ML won't. The pattern on the right, the value on the right has to have the structure of the pattern on the left. The two things have to have the same structure. And then the variable in this side is matched with the appropriate value on the right. In this case, they don't match. X can match with 4, Y can match with 5. Oh, but 6 doesn't have anything to match with. So this thing fails. That would be a fail match. Okay, that match fails. Okay. Now, here's another interesting idea that ML lets you do. My pattern is a pair of two things. There's one thing, there's another thing. Where this thing in the pattern is another pair. So this thing is a pair where the first thing in the pair is a pair. Over here, I have that, a pair and a thing. Okay. Y matches 6, X matches 4, and this underscore says match, but throw away the value. It doesn't create what we call a binding. I'm not declaring a variable there. If I put a Z there, Z would be 5, but I put an underscore. Underscore is a special character. It matches anything, but doesn't create a binding. It doesn't declare a variable. So here out of this thing, I'm picking off the 4 and calling it X, and I'm picking off the 6 and calling it Y. So now notice that the X ends up being an integer variable, 4. X is not a pair. Like over here, X is the integer 5, Y is the string cat. Here, X is the integer 4, Y is the integer pair 5, 6. Okay, I'm not creating a variable that holds this thing. I'm creating two variables, one that holds this guy and another thing that holds this. Okay, we're going to see how this gets used. It turns out this is one of the most brilliant ideas in all of computer science. People who have studied these things and have used it have really said that this is one of the best ideas that ever came up in computer science. Pattern matching is really a great idea. And like I've said, Java is now using it, C++ is now using it, JavaScript is now using it. It's taken, pattern matching was put in ML back in the 70s. And it's literally taken 40 years for the world to realize what a great idea this is. It turns out you can write extremely elegant code when you start getting used to pattern matching. When you have a language with pattern matching, it allows you to write very, very elegant code. We'll see as we go along how, but it's kind of confusing at first. So we're going to try to describe it carefully, and then we'll start seeing how it can be used to write really nice. What it does, actually, it gets rid of huge numbers of if statements and case statements. We'll see that pattern matching is an extraordinarily elegant way to get rid of lots of ifs and cases. Okay, and some people actually call pattern matching case statements, though we'll see that that's not a very that's only one way to use pattern matching. But some people mistakenly refer to it as essentially a case statement. Okay, so it's going to eventually give us a way of getting rid of if statements and writing code that's really concise and easy to read without bunches of if statements. That's what's going to eventually get us to. Right now, we just have to figure out what it does. Okay. All right. The underscore is a nice little trick. It lets you match part of a value, but not use that value. Okay. Like over here, okay, X. Now, my pattern says I should have a pair. X will be the first thing in the pair. Then the second thing in the pair is another pair. I don't care about the first thing in this pair, but I want the Y to be the second thing in the second pair. Okay. So when I match it with this right-hand side, X is 4, Y is 6. Now look, that same pattern matches this right-hand side too, because this pattern just says that X is the first thing in a pair. Well, there's the first thing in a pair. So X is 4, 5. Then here is the second pair. In this pair, the 5 is ignored and Y is matched to the 6. Okay. Now I can actually, here I can take these two and copy and paste them into ML. So I'm going to just copy and paste that into the ML. Do I have ML running? Well, I'll just start up another ML. Okay. So you can see that here, X matched to 4. X is 4. Y matched to 6. Y is 6. You know, the 5 didn't get used. Now, in the same pattern, but a different value, now the X matched to the pair 4, 5, and the Y matched to the 6 still. Okay, so this pattern says that X is the first thing in a pair. Okay, so for example, I could go over here and put cat here now. X is now cat, because that was the first thing in the pair. I could go here and put a triple. Okay. On the left, I have X matching the first thing on the pair on the right, and this matching the second thing in the pair on the right. The first thing in the pair on the right is that triple. So that triple matches the X. And then look, let me go over here and replace this 6 with another pair. Okay. This stuff can get hard to read, but we're just kind of like practicing idea. Usually we don't write crazy patterns like this, but as exercises, you see these kind of exercises around a lot. asking you to read patterns and figure out what they're doing. The ML will do it for me, but you should practice reading the pattern and doing it yourself. Okay, the left-hand side is a pair. X is the first thing in the pair. There's the second thing in the pair. It's another pair. Okay, over on the right, there's the first thing in the pair. So X is 4, 5, 6. There's the second thing in the pair on the right-hand side. The first thing in that pair is 5, but 5 matches the underscore, so it's thrown away. The second thing in that pair is the pair 5, 6. So Y matches the 5, 6. So X is 4, 5, 6, and Y is 5, 6. Okay, so practice pattern matching. The thing on the left is the pattern, and the thing on the right is the value. And you want to match the pattern to the value. Okay, and you can go down here and do more examples. Now, this made use of lots of tuples. Now, here's some patterns that are going to make use of lists. List patterns are written using the cons operator and square brackets. Okay. Okay. So, for example, I'll type them over here. Val, I'm declaring X and Y. So I'll read this. I'm declaring X and Y, but they're the parts of a 2-item list. And the value is 3, 4. Okay. So X is 3, Y is 4. Now I get a little warning here, and we'll see how that warning is, why that warning is there. Okay, when you start doing patterns with lists, you can start getting these warnings. But notice it did bind the X to 3 and Y to 4. Okay, I can do that one again. Like over here. Now notice I can't put a pair here. Why can't I say, oh, X binds to 3 and Y binds to the tuple 3, 4. Does anybody see what's wrong with this? It's a little bit subtle. Kind of looks appealing. X is 3, Y is the pair 3, 4. Think arrays in Java and lists in ML. What about them?
They can only have one specific type
They,
per
pardon me?
list. You can only have one specific type per
Right.
list.
Right. Now, what have I put in my right-hand side?
Do you have one integer and one tuple?
Yeah, so they're not matched up. The list is an inconsistent list. The problem's not the pattern on the left. The problem is the list on the right. The list on the right is inconsistent. It's not a proper list. But watch if I do this. What's X?
The 5, 6.
5, 6 tuple, and the Y is the,
Tuple of 3 and 4.
yeah, and the list is a list of tuples. So it's a list of tuples, and the X is the first tuple, and the Y is the second tuple in the list. Okay, right? Now, here's one reason why that thing is not, here's the problem. What if I put a list of 3? Okay. Here's why I'm getting that error message. Does anybody see what the problem here is? The pattern says what? What's that pattern? Square bracket means what?
List.
List. Square bracket, so it's a list of, now you don't know what type, but it's a list of 2 things. Okay, so this matches a list of 2 things. But what's on the right-hand side?
3 things.
3 things. And it won't like my pattern. See, because I said specifically a list of 2 things, on the right, I have to make it a list of 2 things. And that's got to do with this warning that I'm really, lists, I should be doing this in a slightly better way, okay? But the pattern was specifically list of 2 things. If I make it a list of 3 things, now it matches, okay? Now, what if I want all those numbers in the pattern? See, now I'm matching a list of 3 tuples. And on the right, I have a list of 3 tuples. And I'm declaring a whole bunch of variables. Notice that when I'm not declaring any tuple or list variables, x, y, z, x, y, u, v, and st are all integer variables. After I'm done with matching the pattern, these variables only have the type of what they matched with. So even though on the left I had a list of tuples, what I declared were not anything to do with list of tuples. I'm pulling values out of this right-hand side. What the pattern matching is letting me do, oh, this is why JavaScript actually calls this deconstructing or destructuring. I'm pulling apart that value into pieces and giving the pieces name. So if you want to read another description of this, now JavaScript is a very commonly used language. ML is not that commonly used. So ML pattern matching, there's not a lot of stuff on the internet about ML pattern matching, but JavaScript destructuring, there's tons of stuff about it. Let's see. Oh, there's tons of stuff about JavaScript destructuring. Okay, and you can read. And essentially, they called it destructuring, not pattern matching, because they looked at this, and I think it's not a bad way to think about it. You're pulling apart that structure. You're destructuring it into pieces. Here, I destructured it completely into all the numbers in it. Up here, I destructured it into just the pairs. Okay, so I destructured it one way over here, and I destructured it a different way here. Over here, my x, y, and z were the pairs in the right-hand side. Here, my x, y, u, v, and st are the individual numbers. Okay, so I think it's actually not a bad name, destructuring. See, notice destructuring assignments. Okay, see, we're assigning a value, we're pulling apart a value and assigning its parts to variables in a pattern. Okay, so it's an assignment that's destructuring. So JavaScript referred to as destructuring assignment or just destructuring. They almost never use the word pattern matching in the JavaScript world. They don't refer to it as pattern matching. They always refer to it, but I mean, they know that it is pattern matching in ML. That's where they got the idea from. Okay, so you can look at these examples, especially if you're teaching yourself JavaScript or if you're learning about JavaScript. Now you'll see where JavaScript is getting one of its key ideas from. And this is new in JavaScript. This was put in JavaScript 6, which was the 6th version of JavaScript, ES6. So it's something that didn't appear in JavaScript for many, many years. I think it took 20 years for it to get into JavaScript. Okay, so the original JavaScript, ES5, ES1, ES2, ES3, ES4, and ES5, the original 5 versions of JavaScript did not have destructuring, did not have pattern matching. At some point, the people in JavaScript said, that's a really good idea. We need it in our language too. So they put it in the language. Okay, now let's look at some more examples. Okay, here's a better way to do pattern matching with lists. Okay, this is read as something at the beginning of a list. So this is the cons operator. It says that this guy is at the beginning of a list. What this does is it matches U to the 3 and the V to the tail of the list. This is essentially a way of saying head and tail in a very elegant way. So this is one of the things I'll tell you about how this works real elegantly. This essentially we almost never use head and tail in ML programming. If you looked at thousands of lines of code of ML programming, you'll almost never see the head and tail functions being used, because you almost always do this pattern match. U const onto something. Yeah, you don't have to use the letters U and V. In fact, the way people tend to, the style in ML is to do the following: val x const onto x's equal or I might write it y const onto y's. The idea is that this is what people like to write. I have a list of things that I'll call the first thing y, and the rest of them are the rest of the y's. Okay, so y is one, and the y's, the rest of them are okay. And what you would rarely ever hear somebody say something like head, tail. Okay, you won't see people do it like that. They'll usually just abbreviate, x and x's, y and y's, the first thing in the list and the rest of the list. Now, what's real elegant about this, I can do the following: x in front of a y, in front of a z, in front of the, well, here I would say z's. So this is a list that has, I'm pulling out oops, I have too many colons there. What this is doing is I'm destructuring a list into its first, second, and third item, and then this holds everything that's left. So x is 1, y is 2, z is 3, and the z's is what's left, the 4 and the 5. Okay. Now, if I gave that thing too short of a list, I'll get an error. Well, actually, no, I didn't get an error. Let's see. Oh, I didn't make the list short enough. Oh, no, I see what I got there. See what x is 1, y is 2, z is 3. What are the z's? What's left after I take out the 1, 2, and the 3? What's left of this list after I took out the 1, the 2, and the 3?
An empty list.
An empty list, and that's what it matched. So the z's is the empty list. Very nice. Now, what if I really made it too short? Okay, now there isn't a z item. See, now I got a failed pattern matching. Okay, so it failed here. See, it's not exhaustive binding failure. Binding is the technical word for these assignments. X is bound to 1, y is bound to 2. In a lot of programming language theory, they like to use the word binding. Okay, in the functional programming world, the word binding is essentially the fancy synonym for assignment. Okay, so the assignment, one of the assignments failed. Okay, there wasn't a value for the z because there was the 1 and the 2, and then there wasn't a thing for the z. But what's really interesting is the middle case, when I did it just right. X, Y, Z, Z's. There's the X, there's the Y, there's the Z. Then the Z's is the empty list. Okay. So this is a good way to destructure lists. We destructure lists using the cons operator. It isn't very often that you destructure lists by writing things like X, Y, Z. Now here, watch what happens. Suppose I write X, Y, Z equal 1, 2, 3, 4, 5. See, this isn't going to work. Remember, it worked when I wrote X cons. We read this as cons. X cons, Y cons, Z cons, Z's equals 1, 2, 3, 4, 5. It worked. What's going to go wrong here? This is a bad pattern on the right, on the left. What's kind of bad about that pattern? What does it match? We did it earlier.
It only matches a list of 3
Yeah,
elements.
it only matches a list of 3 items. What? Oh, I forgot to put the val in front of it. I was doing a comparison. See, I forgot the val in front of it. So I was actually doing a comparison, and those two didn't compare. I got false. That was not equal to that. Okay, so I forgot the val. See, it didn't match. I can actually kind of force this thing to match. I can say that I want that list of 3 items to be concatenated on some Z's. I think this will work. Let's see if this works. Now I'm saying that my pattern is a list of 3 items concatenated on another list. I guess the concatenation operator can't be used in a pattern. Let's see. And I can't use cons here if I remember right. No. What that does, that says that this is a list of lists. And that's saying that it's a list of lists of 3 items. So that's saying that this is saying the first item in the list is a list of 3 items, and that's the first item in a list of rest of lists of 3 items. So this doesn't give me what I want. I thought, you can't use the cons operator there. I don't even think you can fix this. I don't remember if there's even a way to fix it. You only use pattern matching with square brackets if you really, really, really want exactly a list of that length. That's saying I want a list of exactly that length, which isn't very often. Usually you want to be more general about your programming. So this pattern is only really good for matching lists of exactly that length. So if I make it exactly that length, fine. Okay.
Quick question.
Yeah.
I think I missed what the ZS was.
The rest of the list. Okay, so this was supposed to be the rest of the list, but the at operator, the concatenation operator, see the at operator puts 2 lists together. It's the concatenation operator. For strings, the concatenation operator is up arrow. For lists, concatenation operator is at sign. What I wanted that pattern to say was, I wanted it to be a list of 3 items concatenated on the rest of the list. But that pattern doesn't work.
Oh, did you make a list that was named ZS or something? Is that what that is?
That's what it's trying to do. See, that's a pattern match. It's trying to make that a list. Now, the way I should do that is the following. I should say X const onto Y, const onto Z, const onto the rest of the list.
So sorry, so ZS is insignificant. That's just the name that you chose.
Plural of Z.
Oh, okay. I thought it was something else. Thank you.
No, it's a clever little it's a little idiom that ML programmers use all the time. I have an X, a Y, a Z, and the rest of the list, the Z's. Okay, the Z's are the rest of the list. I could have said, now Alice is the rest of the list, but ML programmers like to do X, Y, Z, and Z's. Or if they just want the first two items in the list, Y's. Now notice that they wouldn't do that. Oh, sorry, they wouldn't do that. An ML programmer wouldn't do that. That's confusing. Why? Bad style. Not wrong, bad style. Why?
It looks like you're just trying to take in three, like a list of 3 elements.
Well, yeah, it's kind of like you want an X, a Y, and a Z. But really, what's this going to give me? X is going to be,
Would it be 1, 2, and 3?
well, no, that's what it's not going to be. X is going to be 1, then
Y would be 2,
yeah, and what's Z?
just 3.
No. What's
Oh,
left
the
in the
rest of
pattern?
it.
What?
It would be the rest of it.
Yeah, Z would be the rest of it, but that's confusing. So an ML programmer would say, to make it more readable, the rest of it, Z's, X, Y, or actually in this case, it would usually be X, well, the Y's. A lot of times people usually think X, Y, and Y's. So you might also see somebody do X, Y, and Z's, but usually it'd be X, Y, and the Y's, the rest of the list. Okay? So X is 1, Y is 2, and the Y's is 3, 4, 5. And then if they were just pulling off the first item in the list, they would write it this way. X and the X's. X is 1, and the rest of the list is 2, 3, 4, 5. So that's a style guide. That's a little style issue of when you're destructuring a list to use variable names for the items you want to pull out of the list. And then when you get to the last thing in this cons, which is going to be the rest of the list, you usually call it the, in this case, the Y's. X, Y, and people use X, Y. People just use, they don't say head or first, second, and rest. One of the beauties of this is the notation is so concise that you can get away with simple variable names. Like Java programmers have to create really long, complicated variable names. It has to do with the fact that Java is kind of not an elegant language. In ML, you see lots of people writing functions with X, Y, Z as their variable names because this stuff becomes actually easier to read. This is saying I want the first items. This is, I'm destructuring a list, and X is going to be the first thing in the list, Y is going to be the second thing in the list, and Y is going to be the rest of the list. And I'm just real used to reading that. Whatever the list is, that X is going to be the first, Y is the second, and then there's the rest of the list. And if I want to pull 3 things out of the list, I would do Z with, then I would say the Z's. Okay, so I'm getting an X, Y. Oh, I put too many colons in there. First, second, third item in the list, and then the rest of the list. Okay, it's very readable. You will not have ML programmers complain about variable names like X, Y, Z if you use it in this pattern. If you're writing these kinds of patterns, these kinds of variable names work real well. Okay, all right. So we've got patterns in tuples and patterns using lists. And then if you want, you can mix tuples and lists together. So you can make patterns where you have a list of tuples or a tuple of lists. Like this is a tuple with a list inside of the tuple. This is a list with a tuple inside of the list. Okay, here's a list. I'm sorry, here's a tuple with a list inside of the tuple. Okay, and now here I didn't pattern map. I didn't deconstruct it. I just let A be all that. Right? Now look over here. A is that value. So I'm matching this pattern on that value up there. Now this can be hard to read because this is not good programming style. Here's a pattern, and I can't tell what I'm matching it on. This is bad. This would be considered bad style because it looks like, how the heck do I tell if this thing matches that thing? Well, I have to go back up here and read what that thing is. But the way ML looks at it is that's a value. So it just evaluates it to its value and then matches. So B is cat, C is 1. The underscore is the rest of the list. The underscore is the 4 thrown away, and the D is the 5. Let me just show you that real quick. That's not very well written. Okay. B is the cat, C is the 1, and D is the 5. Okay. So that was a very messy way to write a pattern, but it's practice in reading. Sometimes people, as an exercise, you don't have control over the world. There are people who write lousy code, and you have to read their lousy code. So you can't just say, I don't want to read that because it's ugly. If somebody wrote it and then they stick it in front of you, you have to read the ugly code. You may not ever write it yourself, but it will get stuck in front of you. You will get stuck reading somebody's ugly code. So you have to get used to reading the ugly code too. Okay. So then the next thing on Thursday is how do we combine this with functions? The real goal is to combine pattern matching with function definitions. Okay. So we've described pattern matching in assignments, but what we really want to do is describe pattern matching in functions. And then we're going to use it for defining functions in real elegant ways. Okay, so look at these examples and practice thinking in terms of matching a pattern to a value. Match a pattern to a value. Match a pattern to a value. And just make sure you can understand how all these patterns match to the values. And then we'll see how to use them in function calls, and function definitions, and in function calls. Okay? All right, so we've run out of time. And I'll go ahead and stop the sharing. If you have questions about this, come to office hours or send me email. Remember, there's a new homework assignment. We didn't really look. We'll look at the homework. We'll look briefly at the new homework assignment on Thursday. Okay, so we'll look briefly at it on Thursday. And any last question? Anybody got a second question? Okay, I'll go ahead and stop sharing. And see you on Thursday. Bye.